Hi, Bennett here. We're going to be drawing a graph by using this equation, and to do that, we will first find our factors. For our first factor, we have x equals 0. Our next one is x plus 5 equals 0, and our last one is x minus 2 equals 0. From these factors, we can find our roots, or otherwise known as our x-intercepts. The first one is given. We've already solved for x, but for the next two, we need to get x by itself. So we subtract 5 from both sides with this guy, get x equals -5, and with the other one, we add 2 to both sides, and get x equals 2. So that means that our zeros, also known as x-intercepts, are 0, -5, and +2. Looking at these in the equation, we saw that the first two had multiplicities of 1, and the last two had a multiplicity, or the last one had a multiplicity of 2. So we will write multiplicity one for the first two, and the last one had a multiplicity of 2. And so for the behavior on the graph, the first two were both odd, so that means they intersect at the x-axis, at their x-intercepts. Oops, I spelled it wrong. They and the last one was even, so that means it bounces. Then we can see that by adding up these multiplicities, our degree of our equation is 4. Then we can see what the end behavior is based on our leading coefficient. And we see that since the leading coefficient is positive, the graph ends up going upwards. And then since our degree is even, this means that it goes upwards in both directions. So these both mean that the everything goes up in both directions. Now, making our graph, we use our x-intercepts, which were 0, -1, 2, 3, 4, 5, and +2. And before we do, we want to pick at least one test point in between each of them. Whoops. In between every two consecutive x-intercepts. So since we have -5, 0, and 1, we'll just pick easier numbers. We don't have to say -2.5. We can just say -2. And we have the y, or the x value, -2, so now we just need to find the y, and we do that by plugging in -2 into our original equation. So we plug it -2 in for x, and we get -2 times -2, I'll do that in a different color. We're plugging in -2, then we have -2 plus 5, and all times -2 minus 2 all squared. This simplifies down to -2 times 3 times -4 squared, which equals -6 times 16, which is equal to -96. For our other test point, we can draw this on the graph real quick. We got the point, -2, -96 from that. We can go to -2, then down to about 96, which is off our page. We can just put it off the page towards the bottom. And then our other test point is going to be between 0 and 2, so we'll pick x equals 1. So we have, looking back at our original equation, we plug in 1 for x. And that equals, we can just multiply the 1 through. We just have 1 plus 5 times -1 squared, which is equal to 6 times, just like +1, which is equal to 6. So our point here is 1, 6. And we can draw that on our graph, 1, 2, 3, 4, 5, 6. So now, putting everything together, we have our points. We know that the end behavior starts in the upwards direction. So we come down. We see that -5 was an odd multiplicity, so it intersects and goes through. But it goes through a little steeper. It goes off the page, in fact. Just have it touch our point, and then it comes back so that it can go through 0, because 0 was also an odd multiplicity. And then it'll cut through +6. And then it bounces at this last point because it was an even multiplicity. We can draw that a little bit better. Really show that bounce. And then to be correct, you want to have arrows on both sides, showing that it's going on forever.